All right, we're going to go ahead and get started. So first of all, my name is Eric Morgan, and I'm a software engineer with MindWare Technologies, and I'm going to be running the webinar today. So today's webinar is the third part of the BioLab Fundamentals webinar series, which we've been doing for the past few months. This is going to be the final entry, and we're going to cover the remaining topics in the BioLab application. So as usual, if you've attended a webinar before, they're separated into two main parts. We're going to start with a walkthrough, where we're going to talk today about acquiring data in BioLab, what the acquisition screen looks like, and some of the different features that are available on it. We're going to talk about using BioLab as a data viewer to open files, modify them post-acquisition, and look at your data. And then finally, we're going to cover some common configurations from start to finish, sort of starting with BioLab as a clean slate and working through to acquiring data. And following those topics, we're going to open the floor for question and answer, which will be the last portion of the webinar. And throughout the webinar, you can feel free to ask questions using the questions panel on the GoToWebinar interface. So we're going to be primarily saving these questions for the question and answer portion to actually respond to them. But you're welcome to submit them throughout the entire webinar, and we'll either answer you privately, or if we feel as though it's beneficial for the group to hear, we'll answer those questions out loud for the group. And we'll start by doing a recap, since this is the third part of the series of webinars on BioLab, and sort of what we covered so far. We learned that BioLab is an application for acquiring and viewing data. It's the center of integration for MindWare equipment. So it integrates the physiology that you're recording with the events that are coming in, whether they're from a digital event source such as a stimulus presentation application, or from a MindWare mobile, or from the keyboard. And it also acquires synchronous audio-video recordings with your physiology. But every lab is different, and the needs of every researcher are different. And as such, our equipment and BioLab are highly flexible to handle a wide range of experimental needs. And so what we've done so far in the first two portions of this webinar series are talk about the configuration screen, because this is where the way you use BioLab is going to change depending on what sort of equipment you're using and what you're studying. That configuration screen contains all the settings related to the setup of channels, so scaling your channels to get them in the correct units, filtering them to remove unwanted noise, naming them so that it's obvious when you go to analyze what that channel contains, things like that. It contains settings related to event setup. So as I mentioned, we can bring in events from a multitude of sources, such as stimulus presentation packages, ePrime, SuperLab, custom MATLAB scripts. Our MindWare mobile has the ability to send wireless events, which we talked about last time. So all of those are configured on the configuration screen. Triggering, so if you're using an external system to control the start and stop of acquisition, that's set up here. The way your files are being saved, so whether you're just acquiring a single continuous file or splitting your file up into epochs, that's all configured on the configuration screen. And finally, the audio-video recording is also set up here. And we ended last time by speaking on the fact that configurations can be saved to a file for either backup, or if you're using BioLab in a lab situation where multiple users are accessing it and using it slightly differently, you can use those configuration files to retain your settings and make sure that you're always acquiring the data that you want to acquire. So we've talked a lot about that, and once you've configured BioLab the way you want to, the next step is to acquire your data. And you're going to do that by pressing the green Acquire button at the bottom of the configuration screen, which is going to bring you to a new screen, which we call the Acquisition screen. Now, the first thing that's going to happen when you go to the Acquisition screen is it's going to prompt you for a file. Now, if you're using Epoch mode, it's going to look a little different, and we're going to touch on that near the end of this section. But if you're using continuous mode acquisition, so you're acquiring a single file, the first thing it's going to do is ask you for a location and a file name where you want to save your data. Now, older versions of BioLab stored the .mw files, and some of you may still be working with those. But with BioLab 3.1 and up, we're storing a new file type called MWX and MWI. And you can see that the pattern that it's choosing to save is .mwi. Now, you need both of these files for analysis purposes, and I'll sort of tell you a little bit about what each file contains and why they're both important. So the MWX file contains the raw data, and this data file is never modified post-acquisition. So you always have this record of exactly the way your data was acquired in that MWX file. And you'll notice the MWX file is a little larger in size because it contains all of that raw data. Now, the MWI data serves as an index to that file, so it makes it easy for us to access that information quickly. And in addition to that, it also stores more information. So if you're doing anything to your file post-acquisition, such as changing filters or scaling, or if you're adding events, all of that's going to be done in the MWI file. And typically when you're opening a file in the MindWare applications, you're going to choose an MWI file to open. But since the MWX file is never changed, we always have the original record, so we can always get back to the original data if you had accidentally added a filter that you didn't want to or something like that. But you do need to keep both for analysis purposes. And a couple quick points while we're talking about files are some file storage recommendations. So when possible, you should always be storing your data locally. And by that I mean storing to the hard drive that's in the computer that you're using to acquire your data. If you store your data to a network location, such as a remote file share that multiple computers can access in your lab, or if you're storing data to a flash drive or an external hard drive that's attached via USB to the computer, those sort of connections are more likely to fail than if you're storing the data directly to the hard drive. And in the event that those connections fail, during the middle of data acquisition, it's possible that your file could become corrupted and your data could be lost. So it's always better to store your data locally and then transfer to those file storage locations after the fact. You should also name your data files well, and you should consider your data organization schemes before you start acquiring data. If you do this afterwards, you could end up with a folder full of a lot of files that weren't named well, and it can be really difficult to determine what file is what when you go back months later for analysis. So a little bit of organization up front can go a long way. And make sure you have permissions to save to the directory that you want to save to. So a lot of times when we're dealing with universities, there are policies and permissions in place to prevent certain users from accessing certain directories. And so just make sure before you decide to save to a directory that you do have the permissions to access it, or else you'll start getting errors from BioLab, and it can be frustrating when you have a subject there and you're attempting to collect data and you run into these issues. So it's always best to figure these things out ahead of time. Okay, so moving on, what we're going to do is go through the various sections of this screen and talk about what the functions are and what the capabilities are. And we're going to start in the upper left-hand corner with the Start, Stop, and Exit buttons. So the green Start and Stop button is obviously used to start and stop the acquisition of data. And the Exit button will stop acquisition if it's currently going on and return you back to the configuration screen and close the file. Both of those buttons do have hotkeys, so Enter will automatically start and stop acquisition, and the Escape key will automatically end acquisition and return to the configuration screen. Now it looks a little different if you're using triggering. So previously we were doing a manual start-stop of our data acquisition. So our start-stop button is enabled and you can press it and start data acquisition. If you're using triggering, you're delegating that responsibility to some external application such as ePrime, SuperLab, MATLAB, things like that. And in this case, you'll notice that the start-stop button, when you immediately come onto the acquisition screen, is disabled. You can't click it. That's because the other application or system is in charge of doing that for you. And you can tell not only by the fact that it's disabled, but by the trigger mode being set to something other than off. And once the trigger is received by the system, that's when the start-stop button will become enabled again and you can manually stop it. Now, the only case where this won't happen is if you're using a trigger mode where you're giving full control to the other system, such as pause high level or pause low level, which we discussed a little bit about last time. In those cases, the start-stop button will always be disabled, and it will always be up to that external system to control start and stop of data acquisition. In the bottom right-hand corner, on a related note, we have an indicator that shows the current state of the trigger line. So if you're having trouble triggering BioLab and you're trying to troubleshoot why that might be happening, you can use that LED to determine the current state of the trigger line and why your system may or may not be sending it the value that you expect. Okay, moving across the top, we now have the real-time event log. So what this shows are events as they come into the system along with a timestamp. So as events come in, whether they're from the keyboard or from ePrime or from a network source, they're all going to show up in here as line items with a timestamp attached to them. And with keyboard events, you can not only use the keyboard to enter those events, but you can also use the event buttons along the side of the screen. And as you press them, you'll see their associated names and types show up in the real-time event log. One special case that I'd like to mention in regards to keyboard events is the F11 event. So we spoke a little bit last time about how the F11 event is special. It's the only keyboard event where the name of that event is not defined before acquisition, but rather it's defined during acquisition. So it's the most flexible in terms of unexpected events occurring during your session. You can use F11 to enter those values and store them as events. So when you press F11, an additional window is going to come up where you can enter what is this event referring to. And what's nice about it as well is it stores a list of previously used events. So if you have events that come up frequently but they don't quite fit into the F1 through F10 keys, you can still very quickly access those through this system. And it's also important to note that the event is logged when you press the event key, not when you press OK on this window. So you can't open this window, preload an event, and then wait for it to happen and press OK. The proper thing to do would be to actually press F11 or any of the F keys as soon as you realize the event is taking place, and that's when the event is going to be logged in the file. Okay, so moving down the right side of the screen below the keyboard event buttons is the journal button. And what the journal is it allows you to make time-stamped notes during an acquisition. Some of the things you might want to make note of are specifics about the subject, such as their height and weight, or the distance between the front electrodes for impedance cardiography, something that's important when you go to do analysis. Or you might make notes about the subject's behavior that they're a little more complex than what you would typically use for an event, or other things of that nature. And the journal screen looks like that. So there's an important distinction between journal entries and events. Events you can use to jump to a specific location in your data for analysis purposes. But the journal doesn't have that sort of functionality. It's in a separate file. It's never used directly in the MindWare analysis applications. So if you want to enter some sort of information that you're later going to want to jump to that location in the file and quickly analyze it, then the event is a more appropriate place to store that information than the journal. But if you're entering something like the subject's height and weight, you don't need to reference a specific point in time when you're looking at that information. You just need to look at the journal, in which case the journal is the appropriate place to do that. Continuing down the screen on the right-hand side, we have the two analog outputs. So if you're using a desktop system, our BioNex, the BioNex has two analog out ports on the back. And these can be used to send voltages to any external system to which they could be connected for synchronization purposes, for control purposes. It really depends on the system that you're connecting to. And the way you would send these voltages is through BioLab on the acquisition screen. So there are two buttons, the right DA1 and right DA2, and then there are voltages associated with those buttons. So if you needed to send a particular voltage to a system that's connected to the BioNex via this analog out port, you would just change your voltage level in BioLab and then press the right DA button to send that voltage. And last but not least on this screen is the actual data display, which takes up the most screen real estate. And in this particular view, we're looking at a stacked plot, meaning that the data channels have been separated into individual plots. Now, there are a couple other ways you can view data, which we talked about last time, and those are the overlay chart and the graph. If you have either one of those, you're going to see a single plot with all of the data channels superimposed on one another. But more typically, the stacked plot is the ideal way to view your data, so that's how we're going to show it here in this example. Another setting that we talked about last time on the configuration screen is the chart history length, which is the setting that determines how much data you're looking at any given time on the acquisition screen. And we can see here that we're looking at 10 seconds of data between 1 second and 11 seconds, and that is what we had our chart history length set to. So that's where that setting comes into play. Now, the way the charts work is they'll automatically auto-scale their y-axis to show you as much data as they can. So it's going to extend the range according to the data that's coming in. So if your data all of a sudden increases in amplitude, that y-axis is automatically going to adjust to account for that. Now, this is typically the way you want to view your data, but there are some instances in which you may not want to do that, such as when you're collecting EMG or sometimes even skin conductance, and you want to very clearly differentiate between the presence of signal, of usable data, and the absence of it. So sometimes when you're collecting EMG, noise can appear as though it's actual data if you're not careful and looking at the y-axis to see what amplitudes you're getting on your data. And so if you want to make sure that you're only recognizing something as good data when it is in fact good data, you can right-click the y-axis and disable the auto-scale, at which point you can adjust the maximum and minimum of that scale so that only when a significant signal is seen is it even visible on the screen. And so this will help if you're new to collecting certain signals and you're just not looking at the y-axis to make it very obvious when something is happening versus when something is just noise. Another feature that we have during acquisition is the ability to do some static analysis on the data live. So this is again accessible by right-clicking on the plots and choosing from a type of static analysis. And we have 3 different types that we can do. We have the time domain stats, which are going to give you very basic stats about a signal. So you're going to get maximums and minimums and RMS, averages, things like that. We have the frequency domain, which we're going to show an example of in a second, which will show you the frequency content of the data as it's shown on the screen at this particular moment. And then we have peak detection, which will attempt to identify peaks in a signal based on a threshold level detection. And so that can be used, for example, with ECG to get a very rough estimate of heart rate for this particular data window. And just an example of how you'd use this, I'm going to pull up the frequency domain static analysis. So we can see that this ECG signal, while it's very usable because we can see those high R peaks, we also see quite a bit of fuzzy noise along the signal. And I'd be curious to know what sort of noise that is, so if we want to, we can filter it out. So I would right-click on the ECG signal and choose the frequency domain static analysis option. And it's going to bring up this window where it's going to show a power spectrum or a graph depicting the frequency content in the signal and the strengths at each frequency. And by using this, we can see that there is a peak occurring at 60 hertz, which is the typical interference that we get from electricity in the United States. So if I were to use this information, I could go back to the configuration screen and apply a 60 hertz notch filter, or I could just keep that information in the back of my mind, and then when it comes time to analyze the data, I can apply the 60 hertz notch filter in the analysis application. So that's just one way in which you could use the static analysis, but there are a number of ways that you can do it, and those tools are all available during acquisition. Okay, so if you're acquiring video as well, you're going to see, and specifically if you're acquiring video using a MindWare video encoder, you're going to see a floating window appear above the screen. And it's either going to be on top of the acquisition screen, or it's going to be behaving like a normal window where you can minimize it or hide it behind the acquisition screen. And that setting is configurable, again, on the configuration screen. If the preview happens to freeze, or if it appears as though it's sluggish, you can right-click on the preview and select refresh, which will refresh that window and possibly, fix the preview issues that you're having. Something important to mention, though, is that the preview is not necessarily indicative of exactly the way the resulting video is going to look. It's purposely shown at a lower resolution and a lower refresh rate just for performance sake. So if your preview looks a little slow, it's not necessarily something to be concerned about, because the resulting video will most likely be better than that. Now, something new in BioLab 3.3 is our integration with Noldus Media Recorder. And if you're using that, then BioLab is going to take care of everything from start to finish with Media Recorder. So when you open up the acquisition screen, you're going to see Media Recorder appear, much like it's shown here. But you don't actually need to interact with it at all. So BioLab's going to launch it. It's going to control the start and stop of the recording, worry about naming the file properly, and it's going to close it when it's done. So the only thing you really need to do with Media Recorder, the application, is configure it, which is something that you would do before you even mapped it in BioLab for use. And those sort of details are found in the Media Recorder manual itself. But once you're on the acquisition screen, BioLab will take complete control, and there's no need to start recording from Media Recorder manually. So we're going to jump back a second and return to something I mentioned earlier, which is how Epoch mode behaves slightly differently from continuous mode. And again, Epoch mode is where you're defining specific segments of time during your session or with your protocol that have a very specific task associated with them, whether you're collecting baseline information, or you're having the subject perform a task, or you're presenting some sort of stimulus, and then maybe a recovery period at the end. You're defining all of these using the Epoch editor, which we showed last time, or maybe during part 1. And then we're letting BioLab take care of naming the files appropriately based on the name of the epoch that you specified. So instead of BioLab asking for a file name when you come into the acquisition screen, it's going to ask for a directory where it's going to store all of those files from each epoch that you're collecting. So that's the difference. That's the first difference that we notice. The next difference is that there's some additional information in the upper left-hand corner near the start, stop, and exit buttons. So there's 2 new buttons, accept and replay, and then there's the epoch list, which should contain all of the epochs that you've defined and their durations. So the way Epoch mode works is once you start an acquisition, BioLab is going to automatically stop it based on the duration that you've specified in your epoch list. And once it's completed that particular epoch, the accept and replay buttons are going to become enabled again. And accept is going to allow you to accept that epoch is being completed and proceed to the next one in the list. If for some reason that epoch needed to be repeated, for whatever reason, whether something went wrong or the subject wasn't able to complete a particular task and you want to give them another chance, whatever it may be, you can hit replay, which will overwrite the previously collected file and start again. So you can replay those epochs. Now, the only time this is going to happen is for the specific epoch that's currently being acquired. So you can't go back 2 epochs and replay baseline or something like that. You can only replay the existing one that you just got finished acquiring. And once all the epochs have been completed, BioLab will automatically exit back to the configuration screen, and that will conclude data acquisition. So that's pretty much everything that we need to talk about on the data acquisition screen. It's fairly straightforward. There are quite a few features, but they're all pretty self-explanatory. So what we're going to move into talking about next is how to view data that you've acquired in BioLab. And to do that, I'm going to bring up the BioLab application, and we'll go through looking at a file together. So here we have the configuration screen, which is what we spent parts 1 and parts 2 talking about. And if I want to open a file, the first thing I'm going to do is go to the File menu and choose Open File, which is going to ask me to select my data file. And you can see that there are a couple different types of files that we can open in BioLab. We can open our older file format, which is the .mw. We can open our new file format, which is the .mwi. Or we can open a video file directly for just video playback. For the purposes of today's demonstration, I'm going to open this mwtask.mw file. So it's one of our older file formats. I'm just going to double-click that. And we can see that the screen has changed a little bit. So it looks the same. All of the same settings are there, but now it's reflecting the contents of the file. The screen almost looks exactly like it would have when you acquired this data. So it's a really nice way to see exactly how the data was acquired, what settings were used, just by opening the file up in BioLab. And you'll notice that all of the previous settings that we've discussed, scaling, the filtering, the channel name, they're all still editable because we can change any of these post-acquisition due to the fact that the raw data has never changed and we're applying these things on top of the data in software. So all these things are still modifiable. We can add filters, remove them, and so on. But we'll notice that the gain is one of those settings that is no longer modifiable. And that's because the gain, again, is hardware specific and it has to be set properly during acquisition because it affects the raw data. So we can still see what the gain was set to, but we can't change it because we're past that point now and we can no longer affect that particular setting. We can go into the Events tab and see how the events were configured. We can even enable or disable them if we don't want to use them anymore. We can change the way we're looking at the data, so the same data display options are available to us when viewing data as there were when we were acquiring the data. But there is one new setting that's available here, and that is the ability to look at data in relative time and absolute time. So relative time is how we're used to looking at data when we're acquiring it or when we're analyzing it, when we're seeing things in terms of seconds, from the start of the file being 0 seconds. But absolute time, assuming that that information is available, will let you view things in clock time. And with an MWI file, you'll always be able to do this. With an MW file, you need to have an associated event file for this to work. And for this particular MW file, I do have an event file, so we can switch between looking at things in relative time and absolute time. And you can change that setting on the viewer screen as well, which we're going to get to in a moment. So I'll show you that as well. Now, the most significant change is the audio-video tab, because we're no longer mapping video sources. We're now choosing files that we want to view that video along with the physiology. And if you've acquired your data using BioLab, so if BioLab acquired the video, whether it's through a MindWare video encoder or through Notice Media Recorder, it's going to automatically find those files because they're named appropriately. And so as long as they're stored in the same directory and they're acquired with BioLab, then they're going to show up here. Now, for the sake of demonstration today, I've slightly modified one of our video files to show you how you can offset it. So I had to go in and manually select this particular video file name. And on the screen, you can also set video offsets if you know. So if you know for a fact that your video started 5 seconds before your physiology, then you can just enter the 5-second offset here. But there's a more interactive way to do it on the actual viewer screen, which I'll show you in a second, that it's a lot more powerful and a lot more easy to use if you're unsure of how your videos are offset. So, and again, everything works here. So we can actually hit the preview button and we can see the file, the contents of the file. So this is no longer live data. This is being read from the file. And you can interactively apply filters, apply scaling, and see what those things do to the data. But I'm going to go ahead and jump right to the viewer screen by pressing the green view button at the bottom. And so now we can see our data file, and we can see our video file. This is one of our former employees, Paul, who made this file quite a long time ago, where he holds up some note cards which indicate an event has occurred, and it's really useful for showing how synchronous the video is with the physiology and for illustrating this video offset tool that I'm going to show you. So that's why we're using this particular data file. Much in the same way as we talked about the last screen, I'm just going to briefly talk about the different features on this window, and we'll go from there. So at the very top, we could see the video playback controls. So if you're used to using our analysis applications, you'll recognize all these functions as play, slow, pause, stop, rewind, and fast forward. And when I press play, you can see the video's playing, and you can see the yellow cursor moving through your data. So that's the current video position in relation to the physiology. And if I pause it, that video will stop playing, and the cursor will stop as well. And we'll come back to the cursors that are on the screen here in a moment. So again, starting from the top, below the video playback buttons, we have some options for determining what portion of data we're looking at. So the window start is going to determine the start of data, so whether we're starting from time 0, or if we want to start looking at 5 seconds in, we can move that and it'll automatically adjust the time window. We can choose how much data we're looking at a time. So if we only wanted to look at 30 seconds worth of data, we can adjust that window size to only look at 30 seconds. And then the cursor position is just this yellow cursor's position, which updates as you drag it, or if you want a specific location where you want to place that cursor, you can enter that value here and the cursor will jump to that location. And that's particularly useful for if you have a very specific time that an event occurred and you want to insert it, you can use that as opposed to dragging it around. It'll be much more precise. And as I mentioned on the configuration screen, that you can actually change between relative and absolute time from this window as well. So if you pay attention to the x-axis along the bottom of this graph, when I change to absolute time, you can see that it's now in real time, so clock time, as opposed to file time. And so depending on how you're used to looking at your data or whether clock time means anything to you, this can be a really nice way to look at your data and make a lot more sense of it. Rather than saying at 60 seconds something happened, you can say at 3:30 something happened. So that is available right here in the playback screen. Again, we have our real-time event log. So much like we were seeing on the acquisition screen, we have all of that event information available here. What's cool about this is you can actually jump to an event by double-clicking it, and it'll jump right to that event in the window. So you can quickly navigate through key points in your file and look at the data to investigate it. On the right-hand side, we have some just general information about the file that you've opened. And then we have a few buttons which do different things. So we have the ability to save the current viewed window out to a text file. Or we can save the entire file to a text file, which is really useful if you're doing your own custom analysis and you want to get the data out of the system and into yours. You can save it all to a text file, which is pretty easy for most systems to read and interpret and then use in your own custom analysis. And we can also print this graph. So if you have a particularly nice segment of signals that you want to print and put up on the wall so that other people using the lab have a good indication of what good data looks like, you can use that print button, print the data, and then use it for that purpose. Now, a major use case for viewing your data in BioLab is being able to insert events post-acquisition. So we obviously have the ability to insert all these events during acquisition, during live acquisition. But if you were ever to miss an event, or if you were logging your events in some other way, maybe by pen and paper, which some people still do, you could come in here in the BioLab viewer and insert those events yourself so that you can take advantage of some of the event-based analysis capabilities of the analysis applications. And you do that by using this yellow cursor tool. You would drag it to the precise location where you want to place your event, and then you can use any of the keyboard events to then insert that event. And you can do that again by either pressing the keyboard button, the actual button on the keyboard, or you can use these blue buttons above the graph to log an event. So if I move the yellow cursor here and I hit an event button, F3, we can see that it now shows up in the event log in the proper location. In the same way that we can add events, we can also remove them by right-clicking. So if we right-click an event and choose Remove, it'll be removed from the list, and it'll no longer be included in your event file. Now, much like most things in our applications, you're not actually modifying the raw data right now. So when you hit Exit, you'll have the opportunity to save it or discard those changes that you made to your events. And if you do want to save them, you can actually save them as a new file. Okay, continuing down, we have this scroll bar, which we could see as we adjust it that the window start and window size values are changing. Well, mainly the window start. So the first little tick mark is determining the start of the window. And the second tick mark is determining the size of the window. So if you want to adjust the amount of data you're looking at as well as the start of the data you're looking at, you can either adjust this start time or you can adjust this window size here. Okay, so, and then below that obviously is the data graph, which we've been referring to a little bit with the yellow cursor that determines position, and then the event cursors, which when hovered over will tell you the name of the event, and they're also shown up in the real-time event log. So lots of different ways to look at what events are currently happening, to look at your data, things like that. What I want to show now is how you would do a video offset. So like I mentioned, so typically you wouldn't see extreme video offsets, especially if you're collecting data using BioLab and you're collecting your audio video through BioLab as well. But sometimes people use different systems to acquire their video, and they're not necessarily synchronous. So you'd want to be able to align the physiology with the video so that you could properly analyze it. And the way to do that is to find a point in your file where something of note takes place, something that you can relate between the physiology and the video. So in this case, Paul is holding up these note cards that depict the event that's taking place. But in reality, it may be that the subject moved and you can see a significant amount of noise in the data stream. Or the subject is facing a monitor and you can see a flash of light from a stimulus presentation reflect in their glasses or something like that. You need to find some sort of relatable content in both the physiology and the video with which to align this information. So, so we can see here that the keyboard event occurred at this point in time in the video, but it didn't occur until this point in time in the file. So in order to align it, I'm going to go to the place in the data where that event occurred, and I'm just going to right-click on the video. And it's going to bring up this video alignment tool where I can adjust the current position of the video using this slider, or I can specify it by frame or by offset, depending on how you're comfortable. And you basically just want to locate the point in the video where the event occurred. And in this particular case is about 1.7 seconds off. So now we can see that the current position in the data aligns with what's happening in the video. So I'm going to press accept. And now we can see as we drag the cursor over the event that the event is actually occurring at that point in time. And if we were to jump to other events in the file, we can see that the entire thing is aligned. So that is a better way to align your videos than by sort of blindly guessing at it on the configuration screen. And again, that's accessible by just right-clicking on that video. Okay, so I'm going to press exit, and as I mentioned, it's going to prompt you if you did add or remove any events to save those changes. I'm not going to save them in this case, but you typically save them, and you can name them a different file name. And last but not least, if you have made any changes to your file, such as adding scaling or filtering, you don't need to save it to the same file. You can go to File, Save File As, and then choose a new name for this file so that you keep your old data in case you want to go back to it, but then create a new file with these new settings that you've put in there, and that way you have a record of where you started. So that pretty much concludes how the file viewer aspect of BioLab works. And what I want to do with the last remaining minutes that I have are go through really quickly a couple of general configurations, sort of from start to finish within BioLab, and show you how you would go from BioLab being at its default settings to a working system with these configurations. And I'm going to start with a single subject configuration where we're collecting ECG, impedance, GSC. We're collecting data. We're collecting video from a MindWare video encoder, and we're using a network camera. So here we can see the BioNex is connected to a subject. It's also connected to the acquisition PC, and there's a camera plugged into the BioNex as well. So to do that, I'm going to switch over to BioNex mode in BioLab. And I'm going to use the setting that we talked about last time, which is reinitialize all to default. And that's just so that I could show you how we would start from scratch and get to this point. Okay, so we're collecting ECG, impedance, and GSC. Now, this particular subject is plugged into the second module in the BioNex, so I'm going to enable the ECG, the impedance channels, and GSC. Now, I know that I want my gain to be set at 500 for ECG, and I know that because I referred to the knowledge base article on the MindWare support site, which says that that's a good starting gain to use. I'm also going to check my channel names and make sure that they're clear and that they will make sense to me when I come back to analyze this data months later. In this particular file, there's only a single subject, so it's okay to leave them simply as ECG, Z0, DZDT, and GSC. If we had multi-subject, we want to add the subject name in here. And so then I'm going to jump right to my preview, because the first thing I want to do before I start acquiring data is preview it to make sure I'm getting good data. So right now I'm hooked up to a BioNex, and this is the ECG signal. And we can see that it's very clean. There's no need for any sort of filtering. So I'm going to move on and go to my impedance channel. Okay, so again, the impedance data is looking as expected, but we might want to scale the data so we can see it in ohms. So I'm going to go to my scale settings and choose slope intercept with a slope of 10. And we can see that now the scaled version of that waveform is in ohms. We can also change the units to ohms. And that all looks good. So I'm going to move on to my DZDT channel. And again, that looks like DZDT. It's a little noisy, but that's because I'm talking right now. So I'm going to, again, scale my data so we see it in units. Now, DZDT is 1 ohms per volt per second. So I'm going to just leave it as a slope of 1, and I'm going to change this to ohms per second. And then finally, I'm going to proceed to my GSC channel. And again, I'm going to scale it. And again, by referencing the support article on the MindWare support site, I know that the appropriate slope for this module is 10. And I'm going to do a quick sniff test by having the subject myself breathe in very deeply to see the response on the screen. And we can see the corresponding response to the sniff. So we can see that we're getting good data here. The data is in the range that we expect it to be, and it's responding to a known stimulus. And last but not least, I'll change my scaled unit to microsiemens. Press OK. So at this point, we're ready to acquire the data. The last thing we wanted to do was to collect a single video using a MindWare video encoder. So I'm going to skip right over to the audio video tab. I'm going to preview my video. which in this case I don't have a camera hooked up, so unfortunately the screen will be black, but this would be the first thing you'd want to do is preview your video, make sure that it looks good, that the video stream is coming up. And assuming that it is, I'm going to press the record and enable button. And we're not able to use append mode with videos because you can't append two videos together, so it switches the mode automatically for you. And now we're ready to acquire this data. So that's a very typical setup, single subject impedance cardiography with one video. I'm going to jump back over to presentation here. And because we're running a little short on time, I'm just going to do one more of these with the Dyadic setup, and then we'll move on to the question and answer portion. And if we have time at the end, I'll come back and I'll do that last example as well. So again, I'm going to pull up BioLab, and I'm going to reinitialize all to default. And for this particular example, we're going to be collecting two subjects, both with MindWare Mobile impedance cardiographs. So they're ambulatory subjects, all wireless. We're going to be doing stimulus presentation using network events. So we're going to be using the new functionality of BioLab 3.3 to send events over the network to BioLab. And we're going to be using network cameras through the media recorder integration. So I'm going to start by changing my acquisition source to ambulatory Wi-Fi so that I can detect these MindWare mobiles. And there is a YouTube video that goes through the MindWare mobile setup process in detail. So we're not going to do that today. I'm mainly just going to get through this part and then get to the configuration screen so I can show you how you'd set BioLab up. So right now we're waiting for the mobiles to be detected by BioLab, which normally takes just a few seconds. Okay, so we see the two mobiles showed up. I'm going to connect to each of them, and as we mentioned, we're going to be collecting ECG, impedance, and GSC, much like we were in our last example. So I'm going to enable the channel I have plugged in for ECG, my impedance channels, and my skin conductance. I'm going to press continue. And I'm going to do the same thing for both because we're collecting the same data from both of them. And now I'm going to press connect. And we're back on the configuration screen. Now, because we're using mobiles, our setup process is greatly simplified. So our data is already going to be scaled for us. The data is typically very clean, so we don't need to apply many filters. So we're still going to preview our data, but we're going to have much less setup to do. Now, because this is dyadic, it's important before we go to the preview screen to pay attention to this channel name. So the appropriate way to do this would typically be to name the mobile after the subject. But in this case, we've named them MindWare Mobile 1 and Mobile 2. So if this is enough information for you to know when you go back to analyze which subject was attached to which mobile, then that's fine. But you can go ahead and change it to something like subject 1 or subject 2 or mother and daughter or however, whatever makes sense for your particular protocol so that when you do go back to analyze, it's very clear which subject is found in which channel group. So I'm going to go ahead and change these to subject 1. Now I'm going to preview my data because you always want to preview your data before you proceed to the acquisition screen. And here we can see my ECG, which I've plugged in upside down. So I'm just going to swap those leads. Okay, and here we can see our ECG. So it looks good. We're happy with that. We can just keep on moving through the channel list and make adjustments as needed. So just like we just went through for the previous example, we're going to go through each of our channels and make sure that the data looks good. But because it's a mobile, we don't actually need to do any scaling. All of that's being done for us. So we're going to go through there. We're going to press OK when we're comfortable with all of our data. Next, we mentioned earlier in this particular example that we're going to be doing stimulus presentation, but because there's no BioNex in this system, we have no choice but to use network events from ePrime to BioLab. And we're going to do that by going to the Event tab and going to network events and turning on UDP commands. So now we're saying BioLab is ready to accept incoming events from ePrime or from whatever stimulus presentation package you're using via the UDP command set, which is described in the BioLab manual as well as on the knowledge base. And finally, because we're doing a media recorder integration, I'm just going to come over here to the audio video tab, switch the Nolus media recorder, and enable it. And that's it. Now we're ready to acquire. So that's how we would get from no settings in BioLab to a system that can do multi-subject with media recorder integration and network events. So at this point, I'm going to take a break from going over examples, and we're going to see what kind of questions have come in over the course of the webinar. And if we have time, I'll jump back to that previous example that I was going to show you. But I'm just going to take a moment to look over the questions, and I'll be right back. Okay, we've got a question about the F11 event. So the question is, will the F11 event always be the same, or will it? Can you change it throughout an existing acquisition? And the answer is it is fully programmable, and it doesn't always have to be the same value. So every time you hit F11, you can hit a new value for that particular event, and that's the value that will be tagged with that event. So let me go ahead and acquire some data here. And I'll show you what that looks like. Okay, so if I press F11, I'm going to see that window come up, and I can enter whatever event has occurred, and I'll press OK, and we'll see the event show up in the real-time event log, and the name of the event is stimulus presented, which is what I typed. Now if I hit F11 again, let's say stimulus presented is another event I want to enter. As soon as I start typing it, it's going to recognize that that's an event I already entered. So it's going to make it really quick and easy to enter similar events throughout a particular session. But it could just as easily be something completely different. So subject coughed. And again, it's going to reflect that new name that I put in. And these are all stored with the data, and it will all be usable when you go back to analyze your data later on. Okay, next question is regarding the chart history length. So whether there's a maximum value, and there is, and that maximum value is 10. And it's actually not ideal to look at much more information than that anyway. Looking at a 10-second window lets you see a number of physiological cycles in most data, so you can get that perspective, but it's not so much data that it can become overwhelming. Okay, I've got a question about configuration files. So do they reload all of the settings within BioLab? So in versions previous to 3.3, they loaded most settings, but they didn't load your summary event file, which is where you define what event values refer to what event names, and they wouldn't load the Epoch files. But in BioLab 3.3, the configuration files now contain all of that information. So it's a complete snapshot of all of your settings in BioLab, even if some of those settings traditionally live in different files. And on a related note, a question about whether you can share configuration files with other labs. And you can, but the caveat is you have to have identical hardware. So if the impedance module from one lab is in a different slot in your BioNex than in another lab, then the configuration file is no longer valid. But as long as you have the same setups, then you can certainly share them. You can share them between users on a computer or between different computers within a lab. Again, just assuming that the hardware is the same. Okay, I've got a question about exporting events, and if you can anyway get the events out of a file to use in a different system, and you can. So I'm going to go ahead and open the file that I had just acquired, which I believe I called test. And from the BioLab viewer, you can go to File, Export Events. And this is going to export the events in a standard MindWare event file format, which is the event file that we used to use with the .mw file format. And this format is also described in a knowledge base article on the support site. So you can go on there, just type in event file, pull that up, and that will inform you on how to read the events out of the system. But the first step is to go to File, Export Events to get that information out. Okay, and then we've got one last question, which is, can I move events that were placed incorrectly? And unfortunately, you cannot do that, but you can delete them and re-add them. So when we were on the viewer screen before, I showed you that you could delete events. So let's say that this second keyboard event was incorrectly placed. I can just remove it. I can drag my yellow cursor to the place where it was supposed to be, hit the F11 key, and since I just entered that event, it's still in my list of recently used values, and press OK, and now we see it's placed in the correct location. So that's how you would go about fixing an event that was not properly input during acquisition or even during file viewing. Okay, so it is a little after 1:30, which is technically the end of the webinar, so I do apologize for running a little bit over. And if anyone needs to go, feel free to go ahead and do so. And I want to thank you for attending. And as usual, we do have a survey that we'd like you to complete on the way out. This sort of gives us some feedback on whether you find the content of these webinars useful, what we can be doing better in the future. So if you could, please do take the time to fill that out, because we do use that information when determining what topics we're going to cover in the future, and what sort of improvements we can make to our formatting. So again, thanks a lot for that. And for those of you that do have some extra time, I can go ahead and go over the middle example that I was going to cover earlier in the webinar, just to complete all the content I was planning on sharing with you. So, and this is actually a pretty brief example, so it shouldn't take very long. So in this particular example, we're again going to be doing a single subject, and we're going to be doing ECG, impedance, and GSC. But in this case, we're also going to be using a transducer, a blood pressure machine. And along with that, we're going to be sending events to BioLab from ePrime, or from some sort of stimulus presentation system that sends digital events. So I'm just going to go ahead and bring up the configuration screen here, and we're going to start by configuring our subject for the impedance cardiography signals and GSC. So again, plugged into the second card, I'm going to enable all the channels on that card for ECG, the two signals needed for impedance, which are ZO and DZDT, and our skin conductance channel. And much like before, I'm going to adjust my gain, and I'm going to go into the preview screen and adjust the filters and scaling as needed. Now, what's different about this particular example is we're using a transducer. So our blood pressure monitor is plugged into the first channel of our transducer card. And we have a knowledge base article on using a particular blood pressure monitor, the CNAP, and how to configure that in BioLab. So what I would do is I would pull up that article, and I would go through the steps of calibrating that instrument here. And so I know from that article that we want our gain to be set at 100. And what's particularly important that I want to mention is the channel naming, because BioLab doesn't know what sort of transducer you're using. It just knows that it's a transducer. But we know that it's a blood pressure monitor. So it would be important for us to note that this is blood pressure in the channel name, so that when we go back to analyze, let's say we're using multiple transducers, we can easily differentiate between them. Okay, and then we're going to be using digital events from stimulus presentation package, and so we need to go to our event tab and turn on those digital events. What I would do here is I would go to the first tab, or whichever port you have your cable plugged into, but most likely the first one. and change your event mode to summary, which is what's typically used with stimulus presentation systems. And then you'd want to come in here and adjust your event names so that they correspond to the values that you're sending from the stim system. So I would come in here for each event that I plan on sending and change the event name to something that makes complete sense, because these are the event names that I'm going to see when I'm doing analysis. So I know that when I send a value of 1 from E prime, I know that that means my baseline is starting. So I probably want to actually name this something like baseline start. And I know when I send a 2 that that's the end of the baseline. So I would change this to baseline end, and so on. So these can be for specific stimuli that are being presented to a subject. These can be for the start and end of tasks like I just showed you. But in any case, this would be an important step to take, because if you don't do this, you're just going to see sync summary event 3, sync summary event 4, and so on when you analyze. And that's not going to be nearly as clear in terms of what actually happened during your session than if you name them appropriately using this system. And finally, because we're using E prime to send events, we're also going to use E prime to control BioLab. So I'm going to come up here to the trigger modes, and I'm going to change it to the appropriate trigger mode, which typically is rising when you're using a stimulus presentation system such as E prime. So now we're set up to do a single subject with blood pressure, impedance cardiography, and ECG, and we've mapped our events to their appropriate values, and we can acquire data. So once you get to know the configuration screen in BioLab well, it can be pretty quick and easy to get from scratch to a workable solution with a variety of common configurations that people use. So it's definitely important to get to know the screen well and understand all of the settings that are available to you. So it doesn't look like any other questions have come in, and we are about 10 minutes over, so I'm going to go ahead and end the webinar there. But again, thank you so much for attending, and I hope you enjoyed this series on BioLab. And as I mentioned a few minutes ago, please do fill out the feedback and let us know what you think, because it is very valuable to us. So thanks again, and have a great day.